So today we are going to see how to calculate the statistical values using Excel, and as well as making of graphs and charts using the data compiled in Excel. So this is a set of data which I have copied from a collection of a huge set of samples from printed papers. So this is a value of black density. So I'll be showing how the calculations are done using black density. So students have to do on cyan, magenta and yellow. So in the batch you can divide into 4 groups. One group will calculate on the statistical values and complete the table, whereas the other 3 groups will make individual charts, graphs for the cyan, magenta and yellow. So this is sample data. So I'll just format it so that it will be clear when we present it to somebody. So this is black density values. So I'll just give a heading black density, and I'll put a serial number. It's very easy to put serial number in Excel. So I'll give a heading, and after that I'll just type 1, and I'll drag this corner till where the data is there. And here in the formatting autofill options, I'll just say fill series. Now it has converted into 1 to 10. And black density is coming slightly outside, so I'll just drag this column. Now I can also do centering of this if I want. And then I'll select all this data and put borders for it so that it will look nice. Now the formatting is done. So next is the calculation part. So I'll just insert 3 lines because there are 3 values to be calculated as per the lab manual. So inserted 1 line. So 2 are already there. 1 more I'll insert. Okay. Now here the value to be calculated is mean. So mean, if I want to find the average of all the values. So in a practical scenario, I may be having maybe set of 100 values. So out of that, if I want to find out the average, it becomes easier with Excel. Simply you just have to select that entire row and just say that calculate the average. So I'll insert the formula here. So I'll just have to say equal to, and the formula for mean is average in Excel. I'll say average. So it is showing already. I'll click on that. So now it has opened the bracket. I have to give the set of cells which I have to take. So first cell I have clicked. Now I have clicked shift and I'll come to the last cell. So now the entire range of cells are selected. Now I'll close the bracket and I should say enter. Unless I say enter, the process is not complete. It will take anything further. If you type, it will take, and that becomes a big confusion. So make it a point to press enter once the formula is completed. The second thing to be inserted here is range. For range, you don't have direct formula in the Excel. So what you do is find out the maximum. So if you try to define range, it is a difference between the maximum and minimum in a set of data. So if I have 10 readings, I have to find out the maximum of these readings, and I have to find the minimum of these readings and find the difference. So that gives an idea like how our process is varying. If the range is too big, that means your process is too much, it is giving too much of variations. So that's why statistical data always prefers to find out mean, range and then the standard deviations. So I'll say max. Then again I have to give maximum among each data. So I have to select this first cell and then say shift, then select the last cell. Now the data set is complete. I'll close the bracket, then I'll say enter. So the range is calculated. The third thing to be calculated is standard deviation. So I'll just write here standard deviation. I'll just give a short form. You can write a full form and format it properly. So again I'll insert the formula equal to, and standard deviation also we have a direct formula. So you can see here standard deviation. I'll click on this, it has come. Now I'll select the first cell, then I go to shift, then select the last cell. Now the entire set of data is selected. I'll close the bracket and say enter. Standard deviation is also calculated. Now this LS and US cell I have written for the graph part, so you need not worry about this. It is a given data, it is not calculated. The meaning is lower specification limit and upper specification limit. So in a process like sand density, all of you know, like printing densities, there is a range of allowable values. So suppose black, this is black. So you can see here 1.38 is the minimum we can allow in black, whereas 1.52 is the highest. So as per the printing industry standards. So based on that you take, it depends on the companies which standard they are going to follow. So they will select these standards. So that is known as specification limits. And when you make the graph, it becomes easier to see. If you give a line for lower specification limit and line for upper specification limit, it becomes easier to see whether the data lies within that range. So that part we'll see when we make the graph. So as far as statistical data is concerned, this is how you calculate it. And it is easier to extend it now further. Suppose I have some column here, sand density, and I'll simply put some random values here. So now if I want to find out the mean for these values also, I don't have to actually insert the formula. If whatever I have done on this first column, I can duplicate on the second column. I just have to click this corner. When the plus appears, you just have to drag. Now the average which is coming is for the second column. Again, range, if you want to see, I'm just going to there is a mistake in range value. That's I'm just observing now. I've written only max, so I have to change this max minus minimum. I have told you it is the difference between the maximum and the minimum value. So again, the minimum formula has to be selected. I have to select this range of cells starting from here to shift here, and then close the bracket and enter. So it is a difference, it is not the maximum. So again, standard deviation, if I want to extend, I'll just drag it like this. So any calculation formulas which are there, if you want to duplicate the same thing, it is very easy to do in Excel. So this part was about the calculation of the statistical parts. So I'll take the data into the next page for the calculation of creation of the graphs. So I'll just need, I'll delete it there, whatever is not. I'll copy this data and I'm going to take it to the next page. So I'll insert here. Now first I'll delete whatever is not needed. So these are statistical values which we calculated, which is not needed for the graph. Delete this. If we need USL and LSL and USL, so I'll bring it to the upper thing. But I cannot put it in this format, so I'll just change the format. This also will have to put like this, insert one column for LSL, because for every value I have to specify what is the LSL, what is the USL. Say LSL, this is USL, upper specification limit, and decrease the size of this column. Again I can give a formatting here. Now I'll put these values. Copy and paste here. I'll copy the entire same data in the entire column, because specification limits remain the same for everything. So now it's nicely formatted. So it's very easy to insert the graphs. I have to just select the data. If I select this data, and say insert, now I will show you scatter. I want it in a line form. So since the values are same, it is going to show me a linear this thing. Now I'll insert the other graphs. I'll right click, sorry, this one. I'll right click on this, say select data and add. So in this I'll say density values. And its values I'll take from here to here. Y values I'll take from here to here. So now I have to add one more column, one more graph for the USL, upper specification limit. So X values I'll give again the serial number, Y values, so this is how my graph looks. And out which is this value, fifth value is okay 1.31. It is going well below the lower specification. This is how you get to see the aberrations, like something going very wrong can be easily identified. So this is a graph for the black density. So you can just do the formatting. You can copy. Format chart area. We do the colors, whatever you want. So this is how you do the chart. So this way you'll have to make for cyan, magenta and yellow, and finally in the lab manual all three charts have to be attached. So this is the bar chart, whereas this is the scatter or the normal graph which we call it in our language. Again there are column charts, bar charts. So I'll just I have given one more file in the data for making of charts. So that chart is separate for like bar chart. Bar chart generally takes a range of data like 1.2 to 1.5. How many values are there? So it is just to give an indication that the peak value.